Assalamu alaikum. In today's class of engineering mechanics, I will teach you how to draw the SF and BM diagram of a cantilever beam when the cantilever beam is loaded with both point load as well as the UDL. So let's first draw the loading diagram. So the question is a cantilever of length 8 meter. So first of all, in loading diagram we need to draw the cantilever because that is very clear. It's a cantilever beam. So we have draw a cantilever. So a cantilever beam is a beam whose one end is free and the other end is fixed. Okay, this cantilever beam is 8 meter length. So the length of the beam is 8 meters and it is loaded with the UDL of 3 kilonewton per meter. So this beam is this time loaded with UDL. So this is the graphical representation of UDL on cantilever, and the magnitude of this load is 3 kilonewton per meter. And there are also 2 point loads of 5 kilonewton and 6 kilonewton are acting at 3 meter and 8 meter from the fixed end. So there are 2 point loads which are at 3 meters. So that is here, that is of magnitude 5 kilonewton, and another is at 8 meters. So that is at the free end, 8 meters, and the magnitude of that load is 6 kilonewton. And they are at the distances of 3 meter, 3 meter, and the another is at 8 meter from the fixed end, that means at 5 meters. So this is the loading diagram which we need to draw first. So now we can go with the calculations. So as I said in the previous example that we need to calculate from the right end of the diagram. So I will do the calculations. For SF diagram. So first of all we have to give the naming. So let's name this A and this point at B and the fixed end C. So we have given the names where these loads are acting. So the beam is CA and these loads are acting at A, B and C. So I will write first SF to the right of A. Is there any load to the right of A? To the right of A is nothing. So that means 0. When there is no load, that means there is 0 load to the right of A. So this is the right of A. So then SF shear force to the or shear force at A. So what is at A? Yes, there is this point load. Yes, there is this UDL, but UDL is very negligible at point A because this is the point A, but there is confirmed point load which is 6 kilonewton and it acts downwards, which we have chosen as positive. So I will write 6 kilonewton at A. Now the same sequence will follow. I will write the SF to the right of, now we have reached here, now to the right of B. To the right of B, there is this point load to the right of B and this UDL. So let's write first the point load which is 6 kilonewton and this point load. See, this is 3 kilonewton per meter. It is separate over 5 meters. So we have to convert this UDL into the load, because it is 3 kilonewton per meter. That means to 5 meters it is 15 kilonewton. That means 3 is the load. It is separated over 5 meters. That means 15. So total load becomes 15, that's 21 plus 21 kilonewton. Now SF at B. As I said in the previous example, that it is the algebraic sum of all the forces to the right of the beam. In this case, that is what SF is. So we are just summing up all the forces. So at B, there is this 21, which was to the right of B, and at B there is 5 kilonewton. So we have to add up that 5 kilonewton. That means to the right at the B, it is 26 kilonewton. Now same way, SF to the right of C, to the right of C. To the right of C is this SF plus this UDL from here to here, which we have not calculated yet. So I will write first plus 26, that we have taken care of this load up to this point. Now same way we have to convert this UDL into the load, that is, it is 3 kilonewton per meter, that means 3, and it is separated over 3 meters, that is 9. So 9, that means plus 35 kilonewton. Then lastly we have to write SF at C. See, at C there is no load, so that means it is same, that means plus 35 kilonewton. This is how we have to do the calculations first, as we did in the previous case. Same, we have to do the calculations first for the SF. Now we will go the calculations for BM. Then I will write BM calculations for BM diagram. Now same way we have to start the calculations from the end A. So I will write BM at A. Which point is going to bend A? Which load is going to rather bend A? So there is point load, but there is no distance, because bending is the product of two, that is, it should have the load and it should have the distance. So it has a load, but it does not have any distance. That means always, which I said in the previous case, that bending at the free end of the cantilever is always 0. Remember this thing, my dear students. Now let's see the bending here. So BM at B. Now who is going to bend point B? So one is the point load, this is going to bend point B, and this UDL is also going to bend point B. So let's take that. So negative, you know, that is hogging, and sagging I have explained in the previous classes. And remember this thing, that BM diagram is always negative in case of cantilever beam. So I will take the negative sign out. So let's first consider the 6 kilonewton. 6 into the distance up to the point B. So that distance is 5 meter. Now we have to consider this one. See how I can do that. First I need to convert this UDL, that is 3 kilonewton, into the load. That means 3 into 5. So 3 into 5, that means I have converted this UDL into the load. Now we have to assume that this is assumption that it's acting at the center. Now this is the load. Now we have to take the distance. So distance is from this point to this point. So how we can take? It's the middle of the 5. So I can say it is 5 by 2. Remember, my dear students, I will say it again. 3 into 5 means we are converting the UDL into the point load. So we have to assume that point load is acting at the center. Now to consider the distance, then we have to do the 5/2 half of taking the half of the distance, because it's acting at the center of this 5 meters, that is 5/2. So let's take how much it is. So it is 30 minus 30 minus 15, 5/2 is 2.5 into 15, that is 37.5. It is minus 30, which is 67.5 minus, and it is kilonewton dash meter. That is the unit which we have to take into consideration. Now we have to find the maximum bending is at the fixed end. Remember this thing also. In case of cantilever, always the maximum bending occurs at the fixed end of the cantilever. So I will write BM at point C. So who is going to bend C? This load, then the UDL. So I will first take this one, that is minus 6 is the point load. Its distance up to point C, it is 8. Then I will take this point load minus, you know the minus sign, why I'm taking this minus sign, 5, the magnitude, and its distance up to C, that's 3 meters. Now I have to take this UDL is also going to bend. So minus, first I will convert this UDL into point load. That means 3, the magnitude is 3, separate over 8 meters, 8. So it has been converted into point load. Then assuming that point load is acting at the center of this beam, so that means 8/2. So let's calculate, let's see how much is the maximum bending. So it is 6 into 8, that means minus 48 minus 15 minus, it is 3 into 8 into 4, which is 96. So plus 15 plus 48, it means minus 159 kilonewton dash meter. That is the maximum bending which occurs at the fixed end of the cantilever beam. So these are the calculations which we need to do first. Now let's draw the diagrams. First I will draw the SF diagram. So for SF diagram, because all values are positive, so that means I have to draw the reference line first. So this is the reference line. Fine. Then all values are positive. So at A, so let's get these points down for the reference purposes. Okay. So at A, SF is 6. And see, this is point load. So in last class also I have said that we have to represent the point load with a vertical line. So I will draw a vertical line, and this represents 6 kilonewton, and it was point A. Then to the right of B is 21 kilonewton. So that means to the right of B is somewhere here. So we have to connect the point load, these 2 points, because it's a UDL. In case of a UDL, we have to connect these 2 points with an inclined line in SF diagram. These 2 points. And to the right of B, it was 21 kilonewton. And at B it was 5 newtons more, that is 26 newton. So because it's a point load needs to be represented with a vertical line. So vertical line. So UDL needs to be connected with a inclined line. That means at this point it is 26 kilonewton. Then to the right of C, it was 35. Again, this is the UDL. So it is somewhere here, 36. So this point. So these 2 points needs to be connected with a inclined line because the load is UDL. So I will connect these 2 points with an inclined line. Then this end, because there is no load at maximum, was the 35 kilonewton. Then this end needs to be closed. We have to close the diagram. And this needs to be hatched. Hatching needs to be done here. And because this SF diagram is positive, so we need to write positive in the middle of the diagram. And this was SF diagram. Now we need to draw the BM diagram. I will draw the one more baseline, like the similar one. This is another baseline for drawing the BM diagram. I will get these points. This is 1A and B, very light. Okay, now let's see the calculations. The BM at A is 0, that means it's here only. So BM at B, so it is 67.5. So let's assume, so it's not to be measured, but approximately I'm writing here. So let's say this point is 67, it's minus, so it's below the baseline. So I will write here 67.5 kilonewton dash meter. Okay, BM at C. At C it is somewhere here. This is the C point. This is the C point. So it is 159 kilonewton dash meter. Now in case of the BM diagram, the UDL, because this is all UDL, and these points needs to be connected with a smooth parabolic curve. Not with a line, but with a parabolic curve. Then this end needs to be closed. This end needs to be closed. And we need to hatch this. These are not the straight lines, my dear. This is a parabolic curve. So this is also a parabolic curve. And we need to close this and hatch this. And this is a minus, and this was BM diagram. So this is how we have to do these questions. I hope you enjoyed this question. If you enjoyed this question, if you are new to my channel, please do subscribe my channel and also share this channel with your friends, and don't forget to press the bell icon. Thank you very much for watching me.